Okay, welcome back to the continuation of 4.3. In this section, we want to talk about the modern square of opposition and how to convert a false statement to a true statement, how that all works together, doing Venn diagrams as well as the modern square of opposition. Categorical argument with one premise. An argument is valid if and only if the information in the conclusion is found in the premise. Using Boolean logic, okay, which is you read about at the beginning of 4.3, an argument will be valid if the premise and the conclusion say the same thing. Using a Venn diagram, we will convert the x to shading and the shading to x if we're going from a false statement to a true one. We can also use the square of opposition. So an example would be, it is false that all dogs are Shih Tzus. Here's a Venn diagram for all dogs are Shih Tzus. Okay, so if it's false that all dogs are Shih Tzus, what are we going to do? We're going to change the shading to an x. And so the diagram would then become all dogs are Shih Tzus. A false all dogs are Shih Tzu becomes this statement here, which is some dogs are not Shih Tzus. Right? So keeping that in mind, using the square of opposition, all dogs are Shih Tzus is an A statement, but it's false. Using the diagonal, we get an O statement. So it is false that all dogs are Shih Tzus, but it is true that some dogs are not Shih Tzus. Okay, and so one of the ways that we make it work, we can do it with the diagram, we can also do it with the square of opposition. So if all dogs are Shih Tzus is false, then some dogs are not Shih Tzus is true. If the premise and conclusion end up being the same, then the argument would be called a valid argument. Okay, so let's look at example number 1. Some petunias are houseplants, therefore it is false that no petunias are houseplants. So if we write them out, we have some PRH, and it is false that no PRH. So for no PRH, we get a shading in the football, right? And that's correct. If you go back and check on page 210 of the textbook, you'll see where that is found to be true. Okay, making it false, we change the shading to an X. Okay, so that's what we've done. When we change the shading to an X, what we're saying is some PRH. Okay, so the premise is some petunias are houseplants. The conclusion is it is false that no petunias are houseplants, but because of using a Venn diagram and converting it to a true statement, we now have some petunias are houseplants. So therefore, we have a valid argument. Okay, so that's example number 1. Let's look at example number 2. Okay, it is false that some animals are vegetarians. Therefore, some animals are not vegetarians. Okay, so when we look at this, we start with the premise. Some animals are vegetarians. But the premise is that it is false. So because it is false, it now becomes this, which would be no vegetarians, or no animals are vegetarians. Right? If we remember back to what a E statement looks like when it's diagrammed. Okay, so it becomes this. The conclusion is some A are not B. Some animals are not vegetarians. Okay, so that's our conclusion. So let's look at it now. We have a premise that says no animals are vegetarians. We have a conclusion that says that some animals are not vegetarians. So since the conclusion contains information that's not in the premise, we would call this argument invalid. So using the square and using your Venn diagrams to convert, work on section 4.3, and I'll see you in class. Bring your questions with you, and we'll answer anything that you may bring.